So in this section, let's talk about exception handling in Java. First, we're going to learn what is an exception, and then how to create exceptions in Java. Then we'll cover the difference between errors and exceptions. And then we'll talk about the types of exceptions. Then we'll learn try-catch block. Then we'll learn finally block. Then we'll learn how to use throw and throws as keywords. And then to wrap it up, I'll give you some useful exception methods. What is exception? An exception is a special type of error. So during the execution of a program, that means a runtime, it's something that disrupts the normal flow of the program's instructions. Abnormal conditions that occur while executing the program will cause exceptions. So while writing the program, these conditions are not known, right? So if you don't consider these conditions, the execution can be terminated abruptly. For example, division by 0 will cause an error in a program. The Java language provides an excellent exception handling mechanism. So these mechanisms minimize the chances of a system crash or abrupt program termination. So for this reason, Java is known as a robust language. The difference between error and exception. So an error is a critical condition that cannot be handled by the code of the program. An exception is the exceptional situation that can be handled by the code of the program. So the important difference between error and exception is that an error is caused due to the lack of system resources, and an exception is caused because of your code or program. But that's what you're here for, and that's what we're going to learn. So let's study some other differences between errors and exceptions along with a comparison chart. So let's have a look at these differences between error and exception in the table. So as you can see here on this table, in Java, errors are defined in java.lang.error as a package, and exceptions are defined in the package java.lang.exception. So an error is caused due to a lack of system resources, right? An exception is caused because of the code. So it's impossible to recover from errors, but you can recover from exceptions by handling them through try-catch blocks. So errors are classified as an unchecked type. Exceptions are classified as a checked or unchecked type. So if we want to give some examples of errors, the Stack Overflow error and an out-of-memory error is certainly a couple of the major ones. And if we wanted to think of a couple of examples of exceptions, we'll call it a class not found exception and the null pointer exception. So come along, I'll explain what I mean. So let's take a closer look at the hierarchy of the Java exception class. And as you can see here in the diagram, object is the topmost class in Java. All the classes extend the objects class by default in Java. That's why it's known as a superclass. So here, throwable is the topmost class of the exception classes, and it's located in the java.lang package. Now, throwable has two subclasses, error and exception. And exceptions have been further categorized in two ways: built-in exceptions and user-defined exceptions. Now, all checked and unchecked exceptions are built-in exceptions of Java. So let's learn these exceptions in detail. Types of exceptions. There are 3 types of exceptions in Java. The first one is the checked exception. Checked exceptions are mandatory to handle. You've got to deal with them. Checked exceptions are generally caused by faults outside of the code itself, such as missing resources, networking errors, stuff like that. These exceptions are checked at compile time, so these are also called compile time exceptions. For example, that file not found exception. That is a checked exception, and it occurs when a file with the specified path name does not exist, or if the file does exist but for some reason is not accessible. The second one is unchecked exceptions. Now, they are not checked at compile time, but they are checked at runtime. So these are also called runtime exceptions. Now, when an unchecked exception is thrown, it is usually caused by a misuse of code, passing a null or otherwise incorrect argument. For example, arithmetic exception is an unchecked exception, and it occurs when you make an arithmetic error, such as dividing a number by 0, like we mentioned earlier. The last one is the user-defined exception. Now, in some cases, we need to define our own exception class for a special purpose based on particular application requirements. For example, let's suppose we have an account in a bank and we have $100 in this account. Now, let's suppose that we attempt to withdraw $150 from our account. And of course, we can handle this scenario by using the arithmetic exception in Java. But it's not particularly meaningful for the user. So in this situation, it is nice to display an error message that is related to insufficient funds. You get the meaning? So we can create our own exceptions in Java. We just need to extend the exception class in order to create our exception. User-defined exceptions are also called custom exceptions, and we'll do a bit of an exercise about these exceptions later. Try-catch block. So if we want to handle the exception ourselves, we can use a try-catch block. In Java, a try block is used to enclose the code that may throw an exception. So a try block consists of a set of executable statements. During the execution of these statements, exceptions can be thrown. Now, a method that may throw an exception can also be enclosed by the try block. So a try block is always followed by a catch block, and we handle the exception in the catch block. So one or more catch blocks can follow a try block. Now, in a catch block, we can use the exception object to print details of the exception. And as you can see here in the diagram, first, the try block is executed, and if the code in the try block throws an exception, the catch block is executed. Multiple catch blocks. So we use multiple catch blocks after a try block. A try block may be followed by any number of catch blocks. Each catch block handles a particular type of exception. Now, before Java 7, we used to catch multiple exceptions one by one, as shown in this slide. But with Java 7 and beyond, if a catch block handles a multiple exception, we can then separate them using a pipe, and in this case, the exception parameter is final. So we can't change it. So this feature actually reduces code redundancy. final block. So the Java final block is used to execute important code such as a closing connection, stream, etc. If an exception occurs in the program, the currently executing method may stop without completing execution. So in that situation, some codes, such as closing a connection, will just never get called. Java provides the finally block to deal with these exceptions. The finally block is always executed whether or not the exception is handled, and the finally block follows try or catch blocks. Now, sure, the finally block is optional, but this block is placed after the last catch block. And if you have a look at the diagram right here, first, the try block is executed, and then if the code in the try block throws an exception, the catch block is executed, and the finally block is executed. And then if the code in the try block does not throw an exception, the finally block is executed again. So let's make some of our own examples with exception handling so that we can deepen our understanding. So first, let's create a new Java project and specify the project name as exception handling. And don't bother changing any of the other options. Just click the Next button. Now in this section, just uncheck the create module info.java file and then press the Finish button. So in this project, just right-click on the source folder and select New Class. Specify the package name as Exception and the class name as Exception Handling, and then select the checkbox to add to the main method. Now let's declare three variables with the int type. First, number 1, and assign it a 0. Second, number 2, and assign a 0 to that. And the last one, result, and assign that a 0. So we will use the scanner class for getting input from the user. And first, we need to import the scanner class. So we'll choose Import Scanner Class in the java.util package to import the scanner class. And we see a message to enter the first int number by using the print method, and assign the next int method of the scanner class to variable number 1. And we see a message to enter the second int number by using the print method. So let's assign the next int method of the scanner class to the variable number 2. Okay, so let's assign number/number2 as an expression to the variable result. And then let's print the value of the variable result by using the print method. And then finally, we should close a scanner object by using the close method. Okay, so you ready to run the code? So on the console screen, we'll enter 12 for the first number and 2 for the second number. The result is 6. All right, so let's run the code again. We enter Java as the text for the first number instead of an integer number. And there it is. See, so we got an exception that's named input mismatch exception. So you see that the program was terminated. So you see what's going on here, right? The next int method could not read the Java text that we entered as an integer, so it threw an input mismatch exception object. Now the second print method message, enter second int number, was not executed. So we want to catch this error and then display our message in the console. And we do that by using the try, catch, finally blocks. And a try block encloses a code which may throw exceptions. So let's enclose that code and let's see if it will throw an exception with a try catch block. The exception that might be thrown here is a input mismatch exception, and so a catch block has been provided to handle it. So we copy input mismatch exception from the console and paste it within the parentheses following the catch keyword. And then we import this class. We must declare an exception type object that's named E. And we will use this identifier to display an error in the next exercises, E for error. So in the catch block, we can display please enter valid number as our message by using the print method. Now let's run the code again. And in the console screen, we enter Java again. And the try catch block handles the exception, and the please enter valid number message is displayed. Cool. So let's run the code again. And in the console screen, we enter 12 for the first number and 0 for the second number. And there it is. We get an exception that's named arithmetic exception. So let's handle this exception in the second catch block. And we'll write arithmetic exception within parentheses following the catch keyword. Arithmetic exception, that's a class that is predefined in the java.lang package. So we don't need to import this class, right? So back in the catch block, we display second number cannot be 0 as a message by using the print method. Now let's run the code again. In the console screen, we enter 12 for the first number and 0 for the second number. The try catch block handles the exception, and the second number cannot be 0 message is displayed. And now if any exception occurs except these two exceptions, we can use a superclass of all the exceptions that are named exception in order to handle it. So let's handle this exception in the third catch block. So we'll write exception within the parentheses following the catch keyword. The exception class is predefined in the java.lang package, so of course we don't need to import this class. In the catch block, we'll display an exception occurred message by using the print method. And then let's add the finally block after the last catch block. The finally block, by the way, is always executed. So in this finally block, we'll display this statement is always executed as our message by using the print method. So now we can run the code again. And in the console screen, we enter 12 for the first number and 2 for the second number, resulting in 6, and there is no exception. Finally block is executed and the message is displayed. So let's run the code again. And in the console screen, we'll enter Java for the first number. It worked so well before. Now the related catch block handles the exception, and please enter valid number is our message displayed. Also, the finally block is executed, and this statement is always executed is the message that's displayed now. So let's enclose the code with a do-while loop. First, we declare a variable isFlag with a Boolean type. Its initial value is false. And we use the variable isFlag in the while keyword. This loop continues until isFlag is true. So back in the code, after printing the result, we'll assign true to the variable isFlag. And if an exception occurs in the code, then the value of the variable isFlag will not be true. So the while loop will continue. Of course, if there is no exception in the code, then the value of the variable is set to true, and the while loop will be terminated. Okay? So why don't we run that code again? And let's enter Java for the first number. The catch block handles the exception, and the please enter valid number message is displayed. Also, the finally blocked message is displayed. And the while loop continues and asks us to enter the first number because the variable isFlag is false. So we enter 12 for the first number and 0 for the second number. The catch block handles the exception, and the second number cannot be 0 message is displayed. And also the finally blocked message is displayed. And the while loop continues and asks us to enter the first number because the variable isFlag is still false. So we enter 12 for the first number and 4 for the second number, resulting in 3. Division operation is done successfully. The variable isFlag is set true, and the finally blocked message is displayed, and the loop then terminates, because the value of the variable isFlag is true. So let's compare throw and the throws keywords by using a table to understand it better. The keyword throw is used to explicitly throw an exception. The keyword throws is used to declare an exception. Throw is followed by an instance. Throws is followed by a class. The keyword throw is used within the method, and throws is used with the method's signature. Also, we can declare only one exception at a time with throw. But with throws, we can declare multiple exceptions at one time. Throw keyword. So we can use the throw keyword to explicitly throw an exception from the code. We can throw either checked or unchecked exceptions this way. And the throw keyword is used in the following method. We'll look at a basic example about throwing an exception from the method. So what you see here is a divide method that returns a double value in this slide. Now, in the method, because we can't divide a number by 0, we'll add throw arithmetic exception and pass a single string constructor parameter, which is the exception message divider cannot be equal to 0. So in our program, we can handle this exception by using our try-catch block. So why don't we do an example with the throw keyword? So in the exception handling project, just right-click on the exception package and select New Class. Specify the class name as throw exception, and then select the checkbox for the main method. Now, outside the main method, let's declare a static double method divide with two double parameters, x and y. So in this method, we will check the value of the variable y. So if the value of the variable y is 0, we'll throw the arithmetic exception by using the throw keyword. We pass the divider cannot be equal to 0 message to the constructor of the arithmetic exception class. If the value of the variable y is not 0, we return the x division y. So let's call this method from the main method. In the main method, we declare a variable d with double type. And we call the divide method with parameters 8.5 and 0 and assign this method to variable d. Okay, so let's run the code. Look at that. Out of the gate, we got an exception that's named arithmetic exception. The divide method is invoked because the remainder is 0. The arithmetic exception is thrown. The message that is passed to the constructor is displayed in the output, and the program is then terminated. Just as we expected, right? So now we have to handle this exception by using a try-catch block. So in the main method, let's enclose the code that may throw that exception with a try-catch block. And we'll copy the arithmetic exception from the console and paste it within the parentheses, following the catch keyword. Also, we'll add the object e. So in the print method, we use the exception object e to display the message and the exception type. Okay, so let's run the code. And the catch block handles the exception and the exception type by displaying the error message, divider cannot be equal to 0. So let's change the parameter 0 with 3.4. And let's print the value of the variable d by using the print method. Okay? Good, let's run the code. The result is 2.5. The catch block is not executed because there is no exception. Throws keyword. So we use the throws keyword in the method declaration. If we know which exceptions can be thrown from this method, we use the throws keyword in the method definition. If you are using a risky piece of code without implementing the try-catch, well, you declare that it throws an exception. So the caller method might handle these exceptions with the try-catch block. But if we call this method from the main class, we can handle these exceptions there. So in our example, we have the void divide method that has no parameters. We throw two exception classes. The first one is number format exception, and the second one is the arithmetic exception. The first, parse int, is the method that throws the number format exception because 8b is not a number format. In the division operation, if the first number is in a number format and the divider is equal to 0, it throws the arithmetic exception. So let's see what that looks like with an example of the throws keyword. So in the exception handling project, right-click on the exception package and select New Class. Specify the class name as throws exception, and then select the checkbox for the main method. Now, outside the main method, let's declare a static void method, divide, that has no parameters. So this method throws the number format exception and the arithmetic exception followed by and separated by a comma. In the divide method, we declare the variable a and assign it parseInt method of the integer class with the value 8b. And we declare the second variable b and assign the parseInt method of the integer class with the value of 0. Now, the parseInt method is used for parsing a string argument into an integer object. And we declare the last variable c and assign it a divided by b. Now we display the value of variable c by using the print method. In the main method, we call the divide method. Now we need to handle these two exceptions that the divide method throws. So let's enclose the code that may throw an exception with a try-catch block. We use the try keyword above the divide method in the main method. And in the first catch block, we handle the number format exception. In this catch block, we'll display the invalid number format message by using the print method. And in the second catch block, we'll handle the arithmetic exception. And in this catch block, we'll display the you cannot divide a number by 0 message by using the print method. Okay, that looks just about right. So let's run the code. So the divide method is invoked first, 8b, and the first parseInt method is not a number format, so this method throws the number format exception. So far, so good. The first catch block handles this exception, and the invalid number format message is displayed on the console. So now let's change the value 8b with 8 in the first parseInt method to test the other exception. And let's run the code again. The divide method is invoked, and because the remainder is 0, the arithmetic exception is thrown. The second catch block handles this exception, and you see it as well as I do, right? You cannot divide number by 0 is our message displayed in the console. Useful methods of throwable class. Java exceptions and all of its subclasses don't really provide any specific methods. The throwable class includes all of the methods. So you see 3 useful methods of the throwable class here in the slide. The first one is the getMessage method, and this method returns the string message of the throwable class. And this message can also be provided while creating the exception through its constructor. So this message is null if the exception object is created with no error message. The second one is the toString method, and this method returns a short description of a throwable. And the third one is the print stack trace method. And this method prints the stack trace information. So are you ready to make some examples with the useful methods of throwable class? I think you are. So in the exception handling project, just right-click on the exception package and select New Class. Specify the class name as throwable method and select the checkbox for main method. And outside the main method, let's declare a static double method divide with two double parameters, x and y. So in this method, we will check the value of the variable y. And if the value of the variable y is 0, we will throw the arithmetic exception by using the throw keyword with no constructor message. Now, if the value of the variable y is not 0, we return x divided by y. Okay, so let's call this method from the main method. And in the main method, we declare a variable d with double type. And we call the divide method with the parameters 5.6 and 0, and then assign this method to variable d. Now let's enclose the code that may throw the exception with a try-catch block. In the catch block, we will handle arithmetic exception. So in this catch block, we'll display the divider cannot be equal to 0 message by using the print method. Okay, so let's run the code. So the catch block handles the exception, and the divider cannot be equal to 0 message is displayed. Excellent. So let's try to use other useful methods of throwable class in the catch block. The first one is getMessage. So let's write the getMessage method in the print method for testing. Now this method returns the string message of throwable class. In the divide method, we didn't pass any message to the constructor of the arithmetic exception class. So this method returns null. Null is simply a value that indicates that the object reference is not currently referring to an object. So let's run that code, and there's the result. You see the result is null. Now, in order to solve this problem, we'll need to pass a message to the constructor of the arithmetic exception in the divide method. So we pass the arithmetic exception occurred message. And, all right, so let's run the code again. And yeah, there it is. So the arithmetic exception occurred message is right there in the console. Now the second method is the toString method. So let's write the toString method in the print method for testing. And this method returns a short description of the throwable class. So let's run the code. You see the type of exception with its package and its message. And now the last method is the print stack trace. So this method prints the stack trace information and returns nothing. So we cannot use this method within the print method because it is predefined with void. So we will call it directly in the code. All right, so let's run the code again. And there you see the result. This method helps to trace the exception. So by using this method, we can see which method causes the exception in which line number. All right. So on the console screen, if you choose the method that causes the exception, Eclipse automatically selects the line in the code. All right, can you handle it? We are doing our 5th project. Yes. So in this project, we're going to develop a menu-driven application to manage a simple bank account. So this application will help us to deposit and withdraw money, and it'll show us our current balance. Now, also in this project, we will create our own exceptions and use them in the program. So first, let's create a new Java project and specify the project name as Bank Account Balance. Now, again, don't go and change the other options. Just click the Next button. And in this section, uncheck the Create Module Info.java file, and then press the Finish button. So in this project, just right-click on the source folder and select New Class. Specify the package name as Bank Account and the class name as Insufficient Fund Exception. Nobody likes to see that, I know. Insufficient Fund Exception is a type of user-defined exception. Remember, we were talking about that. So now we're going to use it. We can, of course, create our own exceptions by extending the exception class in Java. So our balance exception class extends the superclass exception. All right, so in this class, we declare a private variable message with the string type. And also we create a constructor for displaying an error message. So let's declare a public constructor that's named Insufficient Fund Exception and give it the parameter message. And in the constructor method, we'll assign the parameter variable message to the variable message of this class. And now let's create a getter method of the variable message. So for that, we right-click on the file and select Source, Generate Getters and Setters. And we choose the Get Method variable, and then click on the Generate button. And the Get Message method is generated automatically. Okay, so we completed our exception class. Remember to save the code. All right, so now let's create a new class. So right-click on the bank account package and select New Class. Specify the class name as Bank Account. Now first, we'll declare a variable balance with double type. And we declare a constructor that's named Bank Account. So in this constructor, we initialize the variable balance with 0.0 as our value. And we create a public void method, deposit, with one double parameter that's named amount. So in the deposit method, we will assign balance plus amount to the variable balance. And of course, that means that if we deposit the money into the account, we will increase the balance by the added amount. So we create a public void method withdraw with one double parameter that's named amount. And in the withdraw method, if the amount is greater than the balance, then we will throw the insufficient fund exception with insufficient balance. And the withdraw process couldn't be completed will be our message. So in the throw part, we get a compilation error. Now just put your mouse on the insufficient fund exception class, and what does Eclipse do? There it is. So this dialog provides a list of possible corrections. So now we have two ways to handle the insufficient fund exception. We can add throws as a declaration, or we can surround with the try-catch block. If we choose the first option, we have to handle this exception in the main method. And if we choose the second option, we can handle this exception with the try-catch block here, and there's really no need to handle it in the main method. So actually both options are possible. But let's just choose the first option here and go on. So Eclipse automatically inserts the throws declaration in the main method signature. If amount is less than the balance, then we assign the balance minus amount to the variable balance. And that means if we withdraw the money from the account, we will decrease the balance by the subtracted amount. So now let's create a getter method of the variable balance by using a shortcut that you did in the exception class. We'll use the getBalance method for getting the current balance. Remember to save the code. Good. So let's create a main test class that's named test in the same package. So in the main method, we will develop a menu-driven application for choosing a process from the bank account menu. Now first, we create a bank account object that's named account by using the new keyword. And then we need to take inputs from the user by using the scanner class. We choose the import scanner class in java.util package to import the scanner class. Now let's declare a variable choice with no initial value. Now let's start to write the do while loop. Now in loop, in the first print method, we write a title for the program output. So its name is bank account menu. That's right, with all uppercase letters. Now let's copy the print method by using the shortcut and change the code. So in the first option of menu, it's deposit. The second option is withdraw. Third option is show current balance. And the last option is quit. Now in the last print method, we give the select and option message to the user. And we assign the next int method of the scanner class to the variable choice. Now, generally in menu operations, we use the switch case statement. The conditional switch expression is the variable choice. And then this loop is executed until the choice is not equal to 4. So if the user enters 4 from the menu, the loop is terminated. So now we add the while keyword with the choice not equal to 4 condition. And in the first case of switch, we ask the deposit amount from the user by using the print method. And then we call the deposit method from the bank account class by using the object account, and we pass next int method of the scanner class as the parameter. And then we add the break keyword. Now in the second case of switch, before withdrawing money, we'll show the current balance to the user by using the print method. And then we ask the deposit amount from the user the same way. And then we can call the withdraw method from the bank account class by using the object account, and we pass the next int method of the scanner class as the parameter. Hey, did you see that coming? So we got a compilation error. So if you just hover the mouse on the error, Eclipse will show a quick fix dialog. And I'm going to steer you in the right direction. We'll choose the second option to handle with the try-catch block. So we'll change the throwable method with the toString to show the exception type and message. And then we add the break keyword again. In the third case of switch, we'll show the current balance to the user by calling the getBalance method from the bank account class. We add the break keyword again. And in the last print method, we show the message by to the user. If the user enters 4, then this message is displayed. All right. Yes, that's good. That's good. So everything looks correct to me. So let's run the code. And look at that. You see the bank account menu. It's right there on the console screen. So we'll enter 1 for menu choose. It asks the deposit amount. We enter 500 and the menu returns. So let's enter 2, and we see the current balance is 500, and it asks withdraw amount. So let's enter 400 and go back to the main menu again. Now let's enter 3. We see the current balance is 100. So the withdraw process is successful. Now, because we have enough money in the account, right? So let's turn back the menu again. Now let's enter 2. And we see the current balance is 100. So now let's enter 200 for the withdrawal amount. And wait for it. There's the exception message. So yeah, the insufficient fund exception is thrown, and the insufficient balance withdrawal process couldn't be completed message is displayed, but it is as expected. Don't feel too badly. So there it is. We've completed our project successfully. Congratulations and very well done. But you see how useful this is. So I would advise you then to add some new control methods in the bank account class and test the controls using that bank account menu. So now in this section, we will learn the Java desktop application. First, I'll introduce with Java Swing. Then we will play around with Swing containers. And then I'll show you what the JLabel component is all about. Then we're going to learn JTextField as a component. Then the component JButton. And then to wrap things up, we'll have a look at the JDialog class. Introduction to Java Swing. Java Swing is used for enabling large-scale enterprise development of Java applications. It provides a graphical user interface for Java programs. Swing has many rich graphical user interface components to design very useful applications. So we can use these components like button and text box, label, etc., right from the library. So here on the slide, you see the Swing class hierarchy diagram. The base class after the object class is the component class. The component class is a superclass that declares the common features of the graphical user interface, or GUI components. All components in Swing are JComponent, which can be added to container classes. JText, JLabel, JComboBox, JList, JMenuBar, JScrollBar, JPanel, JOptionPane, and JButton as abstract button extend JComponent class. Also, the JFrame extends the frame and JDialog extends the dialog class. Both the frame and the dialog class extends the window class. Swing containers. So in Java, a component is the basic user interface object, and all Java applications include a component. Components include lists, buttons, panels, windows. So in order to use components, you need to place them in a container. So a container is a component that holds and manages other components. So for creating a GUI, I do not say GUI, we need at least one container object, right? So there are three types of containers. The panel. The panel provides space to use and organize components such as buttons and labels. The panel does not contain a title bar, menu bar, or border. Generally, panels are used in the frame. Frame is a top-level window with a title and a border. And dialog is like a pop-up window that pops out when a message has to be displayed. JLabel, JTextField, JButton. So guess what? In this section, we're going to learn some basic components of Swing. JLabel is a class of Java Swing, and it's used to display a single line of read-only text. The text can be changed by an application, but a user cannot edit it directly. JTextField is a class of Java Swing, and it's a text component that allows the editing of a single line of text. And the JButton is a class of Java Swing. It's used to create a labeled button. So when the button is pushed, some actions are performed, for example, save, update, delete, etc. Layouts. Now, layouts are very important in desktop programming. Basically, layouts tell Java where to put the components in containers such as JPanel, Content Pane. Layouts automatically position components within these containers. So every panel or container has a default layout. So if you set the layout to null, it means that no layout manager is assigned and the components can be put at specific XY coordinates. Now, it's recommended to set the layout explicitly for clarity. Now, as you might imagine, Java has lots of layout managers. We will show the grid layout in this lecture. So the grid layout arranges components in a rectangular grid. It arranges components in cells, and then each cell has the same size. So components are placed in columns and rows, and the container is divided into equally sized rectangles. So one component is placed in each rectangle. There's a beautiful simplicity about this, right? Look at that. The grid layout class takes two parameters, that is, column and row. So in our example, we create a frame and 4 JButton components. And then we add these components into the frame. And then we pass a grid layout as a parameter to the setLayout method of frame. And then these components are arranged in a grid layout with 2 rows and 2 columns that are the same size. The grid layout takes 2 parameters and creates a grid layout with a given number of rows and columns. Now, in addition to this, we can add 2 more parameters. We can initialize the vertical and horizontal gap between each of the rows and columns. So, why don't we make a graphical user interface application for our example as to how to work with Swing? So, for this example, we will add some components into a frame, and there'll be panel, label, text field, and buttons. So in the exercise project, just right-click on the source folder and select the new class. And specify the package name as Swing and the class name as Swing Example. And then just select the checkbox for the main method. So now let's create a JFrame object by using the new keyword with My First GUI as the title. So we must import the JFrame class from the Java Swing library. A JFrame is the main window that we will use to display the components we want to show on the screen. So first, we must set a size for the window. So we can set the size of the window by setting the number of pixels. So the method setSize of JFrame allows us to say how many pixels wide and how many pixels long the window should be. And let's set the window 280 by 300 pixels. And then we create a JLabel object by using the new keyword with hello as our text. Now we'll also import the JLabel class. And then we create a JTextField object by using the new keyword with an empty string. And we'll also import the JTextField class. So now let's create 3 JButton objects with string texts. The first object is button 1. Second object is button 2. And the last object is button 3. And also import the JButton class. So let's create a JPanel object to add components into it. We also will import the JPanel class. So let's use the add method of the JPanel class to add components to the panel. And we add 3 buttons, label and text field that we created before into this panel. And we'll add this panel to the frame by using the add method of the JFrame class. And then finally, we will display the frame by using the show method. Okay, so let's run the code. And you see the components right there on the frame. So now we can write a string text field in the text field object to make the display better. Okay, let's run the code again. Okay, so we can see all the components in the window. All the components are added respectively, like in a panel. So the first 3 buttons, and then the label, and then the text field, right? Also, we can resize the window by using the mouse. We didn't put any restrictions in the code, but you can. So now it's time for us to be doing our 6th project. In this project, we are going to develop a login form by using swing components. We will learn how to create a simple login form by using the grid layout. So first, let's create a new Java project and specify the project name, login form, and don't change the other options, just click the next button. So in this section here, uncheck the create module info.java file and just press finish. So in this project, just right-click on the source folder and select new class. Specify the package name as login form and the class name as login form, and select the checkbox for main method. Now, login form consists of username and password fields and the login and cancel buttons. So why don't we create a JFrame object by using the new keyword with login form demo as our title. And we can use Control and Enter key shortcut to import the classes. And now we can create a JPanel object to add components into it. So here we set the grid layout manager for the panel component. Now the layout manager takes 4 parameters. The number of rows, let's set it to 3. The number of columns, we'll set it to 2. And the horizontal and vertical gaps between the components, we'll set it to 15. And now let's create a static method to add components into a panel. Outside the main method, we create a public static void method that is called add components to panel. And it will, let's see, let's give it a parameter jPanel object. In the method, we create a jLabel object that's named userLabel by using the new keyword with the user text. And we also import the jLabel class. And then we create a jText field object, and we'll call it user text by using the new keyword. And yes, we will also import the jText field class. And then we create a jLabel object that's named password label with the password text. So now we can create a jPassword field object that's named password text. And yes, we will also import the jPassword field class. So jPassword field provides specialized text fields for password entry. So for security reasons, a password field does not show the characters that the user types. So we've got to create a JButton object that's named cancel button with cancel as our text. And let's create another JButton object that's named login button with login text. Okay, so now it's time to add these components to the panel. And in order to do that, we'll use the add method of the panel for this operation. So let's add all the objects to the panel respectively. So we add 2 labels, 2 text fields, and 2 buttons. Okay, so let's call this method from the main method by passing the panel parameter. And let's complete the settings of the frame object. Set default close operation. That's the method of frame that is used to specify one of several options for the close button. And we'll use the exit on close option to exit the application. Set location relative to is the method of frame that is commonly used to center the frame on the screen. And we'll pass the null parameter to it. The set size method of frame is used to resize the component. So that'll take 2 parameters. Width set to 300 and the height is set to 150. The add method of the getContentPane method in frame is used to add components into the frame. So we'll pass the panel as the argument to it. And then finally, the setVisible method of frame is used to make the frame appear on the screen if the true parameter is passed. Okie dokie then. So up until now, we have created a frame and a panel in the main method. And then we've created a public static void method. In this method, we have created other components to be added into the panel. And then finally, we have set some properties of the frame. So, don't you wonder what it looks like? Yes, I know your answer. Let's run the code. And there it is in all of its beauty. Our frame is displayed successfully. So you can see the components on the frame. Also, the title of the frame is Login Form Demo. That's the text that appears. And we have used the grid layout with 3 rows and 2 columns. So you see the components are placed in columns and rows with the same sizes. The cancel and login buttons are, well, they're not working now because we didn't add any actions for the buttons. So let's close the window and let's add some actions to the login and cancel buttons. So we need to develop a login module that authenticates users based on usernames and passwords. So for this, we'll just create a static Boolean method to check the username and password if it's correct or not. And if the user enters username and password and clicks the login button, first, it will check the data. And if this data is correct, it will display the welcome message. And if the username or password is false, then it will display the invalid username or password message. So that means we have to create a public static Boolean method, check data with username and password as the parameters. And in this method, if the username equals Java and the password equals 123, then we return true, else we return false. So we will invoke this method from the action code of buttons to check the username and password. Okay, so let's start to write the action code of login and cancel. So first, we will start with the login button. We'll add action listener as the method to the login button object. And then we pass action listener class to this method by just using the key combination Control and Enter. Now, because of the action listener is an interface, the override annotation and action performed method to be overridden are automatically added to our code. In the action performed method, we will call the check data method by passing the get text methods of user text and password text objects. If the check data method returns true as its value, then authentication is successful, and then we can show the welcome message by using the show message dialog method of JOptionPane class. So we pass 4 parameters to this method: parent component, message, title, and message type. The parent component is panel. Message is hello, welcome to Java Swing, by adding the username. So the title is login message. And the message type is information message. J option pane class also has lots of other message types. So if the check data method returns false as its value, then the authentication is failed and we show the invalid username or password message to the user. And we will pass the same parameters to the method except the message type. So the message type is an error message this time. So this type shows error message symbol in the message. And we add the add action listener method to the cancel button object. We pass the action listener class to this method by using the key combination Control plus Enter. The override annotation and the action performed method to be overridden are automatically added to our code, just like in the login button. So if the user clicks the cancel button, the program is terminated normally. So in the action performed method, we use the exit method of the system. If we pass the parameter 0 to this method, we will exit the program successfully. A non-zero status code in the exit method indicates an abnormal termination. So in this section, we have created a method to check the username and password. And we've also added action to the login and cancel buttons. All right, so let's run the code again. And I know you're dying to test those button actions, so let's do it. First, let's try to enter an invalid username and password into the text boxes. So let's enter, John for the username and just anything random for the password. Invalid username or password message is displayed with the error message symbol, so that's as expected. Now let's try to enter a valid username and password. So let's enter Java for the username and 123 for the password. And sure enough, authentication is successful. And look at that. Hello, Java. Welcome to Java Swing is our displayed message. Now, if we click the cancel button, the program is terminated successfully, right? Okay. So we have completed the login form project. So, of course, you can go back in there and add some additional control for the authentication process. For example, if the user enters nothing and clicks the login button, why don't you try giving that a go? Give that a message. Enum types. The enum keyword was introduced in Java 5. Enum is a special type, so it's a list of predefined constants. The main purpose of enum is to define our own data types. Now, generally, the field names of the enum type are in uppercase letters, as they're always constants. So the enum keyword is used to create an enum type. So in our example, we define the color enum type, and the color has some constant values, such as yellow, green, blue, orange, and black. The test code color call equals color.blue assigns a value to the variable color of the enum type color. The variable call can take any of the 5 defined values, but in this case, it's set to blue. So the Java enum type has some very useful key points. Let me bring your attention to some of them, and we'll have a look at them right here. So first up, we can define a constructor in Java enum. Enum constants are implicitly static and final. Enum can be used in switch case like string, int data types. Equality operator and equals methods are used to compare enum constants. So we cannot create an instance of enum by using the new operator. So why don't I show you some examples with the enum type so that we can understand it better. So in this example, we will write a program that displays some colors in enum by getting input from the user. So in the exercise project, just right-click on the source folder and select New Enum. Specify the package name as enum type and enum name as color. In the enum color, we'll define 3 constant colors, red, yellow, and green in uppercase letters, and save the code. So let's create a main test class. Right-click on the enum type package and select New Class. Specify the class name as color test, and then select the checkbox to add the main method. So now we need to take inputs from the user by using the scanner class. And we'll choose Import Scanner Class in the java.util package to import the scanner class. Okay, so we show a message to enter a color by using the print method. So why don't we declare a variable input color with the string type and assign the next method of the scanner class to this variable. Now we'll create the enum instance that's named color and assign the value of method of enum color to this variable. So now we need to use the value of method to convert the string to the enum type. The value of method takes a parameter that's named input color. And we can change the input color text to uppercase letters by using the toUppercase method. And now we can use the switch case statement in this part. The conditional switch expression is the instance of enum color. The first case value is red, and we display the "you entered red" in the print method, and we add the break keyword. So the second case value is yellow, and we can display "you entered yellow" in the print method. And of course, we'll add the break keyword again. The third case value is green, So we display the "you entered green" in the print method. And of course, we add the break keyword again. Okay, so let's run this code. So we enter red in lowercase letters, and it's automatically converted to uppercase letters. And look at that. The "you entered red" message is displayed. Now, if we don't use the toUpperCase method, we will get an exception because we defined the enum constants as uppercase letters. All right, so let's run the code again. And let's enter green this time in uppercase letters. The "you entered green" message is displayed. Okay, so let's run the code again. And let's enter Java. Uh-oh, there it is. We got the exception. And the exception name is illegal argument exception. So the exception message is no enum type constant in enum color, because Java is obviously not defined in our enum class. We defined only 3 enum constants: red, yellow, and green, of course. So, how do you want to handle this exception? By using a try-catch block, you say? Good idea. So in a catch block, we will write illegal argument exception with the object E, and then we display, please enter enum constant type red, yellow, green in the print method. So let's run that code again. And let's enter Java in lowercase letters for color. There we go. The catch block handles the exception, and our message is displayed in the console. Okay, so let's run the code again, and this time let's enter Java all in uppercase letters. Look at that. Our message is also displayed. Proper. So this is good. Then in this program, if we enter except red, yellow, and green values, because that's what we defined, then the illegal argument exception is thrown.